Hello and welcome back. So far, we've done a lot of groundwork. We created extended data types. We created base enums. Still, nothing visible on the screen. No forms. No buttons. No magic yet. But today, things start to feel real. In this video, we're finally going to create our first table for the leave management solution. This table will store actual leave request data. Let's start by understanding what a table represents. In Dynamics 365 Finance and Operations, a table represents stored business data. Every leave request, every employee selection, every date and status, all of it lives in a table. So tables are not just technical objects. They are the heart of the system. Now let's create our table. Right-click on the project. Click on Add. Then click on New Item. In the dialog that opens, under Finance and Operations, select Dynamics 365 Items and then choose Data Model. Select Table and give it a meaningful name. We'll name it Leave Requests. Before adding any fields, let's first understand the table properties at a high level. We are not going to configure everything right now. We will play with all these properties in detail later. For now, the goal is to understand what these properties represent conceptually. Let's start with the appearance properties. Label defines how the table is referred to in the user interface. Title Field 1 and Title Field 2 define which fields represent the record in lookups and references so users can recognize it easily. Next are the behavior properties. Cache lookup controls how table data is cached for performance. Clustered index defines how data is physically stored in the database and mainly impacts performance. Create recID index controls whether an index is created on the recID field and usually stays enabled. Primary key defines the unique identity of each record and is extremely important. Table group tells the system whether the table stores master data, transaction data, or setup data. Visible controls whether the table is visible to the application layer. Now let's talk about concurrency. OCC enabled stands for optimistic concurrency control and it prevents users from overwriting each other's changes when multiple users update the same record. Next are the data properties. Allow archival controls whether old data can be archived. Allow change tracking controls whether data changes are tracked for integrations. Allow retention controls whether data retention policies can be applied. Allow row version change tracking helps track row level updates. AOS authorization controls whether security checks are applied at the service layer. Configuration key controls whether the table is enabled based on features or licensing. Country region codes restrict the table to specific countries. Country region context field is used for region-specific behavior. Created by, created date time, and created transaction ID are system-managed fields that tell us who created the record and when. Modified by, modified date time, and modified transaction ID tell us who last changed the record. Data sharing type controls how data is shared across legal entities. Disable database logging controls whether database level logging is skipped. Disable lock escalation affects how database locks behave under heavy load. Durability defines how data persistence is handled. Entity relation type defines how the table behaves with data entities. Save data per company controls whether data is company specific. Save data per partition controls whether data is partition specific. Storage mode defines how and where the data is stored. Table contents tells the system what kind of business data this table represents. Table type defines whether this is a regular, temporary, or special purpose table. Now let's look at navigation and references. Form reference links the table to a form. List page reference links it to a list page. Report reference links it to reports. Preview part reference links it to workspace previews. Next are lifecycle and metadata properties. Is obsolete is used to mark a table as deprecated without breaking existing functionality. Developer documentation is used to describe the purpose of the table. Modules indicate which application modules use this table. Name is the technical identity of the table and should not be changed casually. Tags help with search, documentation, and tooling support. Now let's briefly talk about inheritance. Supertype and subtype allow tables to participate in inheritance hierarchies. Abstract controls whether the table can store data directly or only act as a base table. Extends defines which table this one inherits from. Instance relation type and support inheritance control how inheritance behaves at runtime. Finally, visibility controls where and how the table is exposed in the system. For now, don't try to memorize every property. Just remember that table properties define how data is stored, secured, shared, and used across the system. We'll revisit these properties in detail when they actually matter. Now let's add fields to the table in the easiest way. Instead of dragging each EDT and Enum one by one, we can add everything at once. Open the Leave Requests table and expand the Fields node. In the project, select all the EDTs and Enums we created earlier. You can hold the Control key and select Leave Request ID, Employee ID, Leave From Date, Leave To Date, Leave Days, Leave Reason, Leave Type, and Leave Status together. Once everything is selected, drag and drop them directly into the Fields node of the table. Dynamics automatically creates all the fields for us in one go. Each field comes with the correct data type, label, and help text. No manual configuration is required. This approach is faster and also reduces mistakes. Because we are reusing EDTs and Enums, the table stays consistent and easy to maintain. This is one of those small tricks that saves a lot of time in real projects. And just to be clear, if you ever need to add a field without using an EDT, you can do that as well by right-clicking on the Fields node, selecting New, and then choosing the required field type directly. But as a best practice, whenever a field has business meaning or is used in more than one place, always prefer using an EDT. Now let's talk about field groups. Field groups define how fields are automatically selected and shown in different parts of the application. They play a big role in lookups, reports, list pages, and forms. Every table already comes with some default field groups. The first one is AutoIdentification. This group is used to uniquely identify a record. Typically, we add fields like Leave Request ID and Employee ID here. Next is AutoSummary. This group is used to show a quick summary of the record. For the Leave Requests table, we add Leave Request ID, Leave Type, Leave From Date, and Leave Status. Then we have AutoBrowse. This group controls which fields appear when users browse records, such as in list pages. Here we add the most important business fields like Leave Request ID, Employee ID, Leave Type, Leave From Date, and Leave Status. Next is AutoLookup. This group controls which fields appear in lookup dialogues. To help users quickly recognize a record, fields like Leave Request ID, Employee ID, and Leave From Date work well here. Then we have AutoReport. This group is used by reporting tools to automatically pick fields. Adding key business fields here makes reports useful without extra configuration. For now, we don't need to create many custom field groups. We will mostly populate these existing groups properly. This keeps the design clean and aligned with platform standards. Well-defined field groups reduce UI work later, make lookups meaningful, and improve reporting out of the box. In short, field groups quietly do a lot of heavy lifting behind the scenes, even though we don't always notice them. Now let's talk about what we will create for our Leave Requests table. For now, we'll keep things simple and practical. We will create a custom overview field group. In the overview group, we add Leave Request ID, Employee ID, Leave Type, Leave Days, and Leave Status so users can quickly understand the record and list pages. Leave Status is especially important here because users want to see the current state at a glance. We don't need to touch system fields because the system manages those automatically. We also don't need too many custom groups at this stage. The goal right now is clarity, not complexity. Well-defined field groups make form design easier, list pages cleaner, and the overall user experience much better. Later, when the solution grows, we can always add more field groups. Now let's move to the next important concept, indexes. Indexes are all about performance. They help the system find data faster. Think of an index like the index in a book. Instead of reading every page to find a topic, you go to the index and jump directly to the page you need. Indexes work the same way for tables. Without indexes, the system would have to scan every record to find what it needs. With indexes, it can locate data quickly and efficiently. Let's take a simple example. Imagine you have thousands of leave requests in the leave requests table. If the system needs to find a leave request by leave request ID and there is no index, it has to check every row one by one. If we add an index on leave request ID, the system can jump directly to the matching record. That's a huge difference in performance. In Dynamics 365 tables, indexes are defined directly on the table. We can create different types of indexes depending on the requirement. For example, we can have a primary index to uniquely identify records, and other indexes to support frequent searches. At this stage, we just need to understand why indexes matter, not configure every option. In upcoming videos, we'll go much deeper. We'll look at different types of indexes, how they work in SQL, and how table indexes translate to database indexes. We'll also see real examples of how the right index can improve performance and how the wrong one can cause issues. For now, remember this. Indexes are not about business logic. They are about speed, scalability, and user experience. Now let's create an index for our leave requests table. Indexes help the system find records faster, so we create them based on how data will be searched. In our case, leave request ID is the most common way to identify and fetch a leave request. So it makes sense to create an index on leave request ID. To do this, open the leave requests table and expand the indexes node. Right-click on indexes and select New, then Index. Rename the index to something meaningful, for example leave request ID IDX. Now select the index and go to its properties. Set the Allow Duplicates property to No, because leave request ID should be unique. Next, expand the index and right-click on the fields node under the index. Click New and select Leave Request ID as the field. This tells the system that this index is built on the Leave Request ID field. With this index in place, the system can quickly locate a leave request using its ID. Later, we may add more indexes based on reporting or lookup requirements. For now, this single index is enough to support good performance. In upcoming videos, we'll analyze these indexes at the SQL level and understand how they actually work. Now let's briefly talk about a few more table concepts, just at a high level. We won't configure these right now, but it's important to know what they are. First are full text indexes. Full text indexes are used when you want to search inside long text fields, like descriptions or comments. Instead of exact matches, they allow searching by words or phrases. We don't need full text indexes for our leave requests table right now, but this is very useful in large systems, and we'll cover it in detail in a separate video. Next are relations. Relations define how one table is connected to another table. For example, linking a leave request to an employee record. We don't have any relations yet, but this is a very important topic. We will definitely cover table relations in a dedicated upcoming video. Then we have delete actions. Delete actions control what happens when a record is deleted. For example, should related records be deleted, blocked, or left untouched? This is critical for data integrity, and we'll look at it later when we introduce relations. Next are state machines. State machines control how a record moves from one state to another. For example, created to approved to rejected. This is commonly used with status fields and business processes. Next are methods. Methods contain business logic written in X++. This is where calculations, validations, and automation happen. We'll come back to methods later when we start writing code. Finally, we have events. Events allow us to react to actions like insert, update, or delete. They help us extend behavior without modifying core logic. We'll cover events when we talk about extensions and customization patterns. For now, just remember this. All these pieces together turn a simple table into a powerful business object. We'll explore each of them step by step in upcoming videos, when the time is right. Alright, that brings us to the end of this video. At this point, our table is no longer just a table. It has structure, meaning, performance support, and future potential. We've talked about fields, field groups, indexes, and a few advanced concepts that we promised not to unleash on you just yet. If your brain feels a little full right now, that's a good sign. It means you're learning things that actually matter in real projects. Remember, good dynamics development is not about clicking fast. It's about thinking ahead so future you doesn't have to panic later. In the next videos, we'll turn all of this into real working screens and logic. That's where things start to feel fun and dangerous in a good way. So grab a coffee, stretch your legs, and don't worry if everything didn't stick the first time. Even senior developers pretend they remember all of this. Thank you for watching, and I'll see you in the next one.